This session will be how to program an encoder. For this example, we'll use the Grayhill 63R256 encoder, which gives 256 pulses per revolution. You'll need to connect your encoder as shown on this diagram. We have the A channel connected to digital input 0 and the B channel to digital input 1. To get started, we'll open the H file and the CPP file. We're going to go to the class documentation, go to the FRC namespace. Let's go find E for encoder. This is encoder. This is our include that we will need. We'll put this at the top of our include file for this project. We'll save this. We're going to create an object of type encoder. We're going to use get to see what the value is. And then we'll set the get distance per pulse. We'll only have to set that one time. And we can get distance per pulse to see how far we've driven. Next we'll come down here. Next we'll come here and create the object. Let's just call it left encoder. We'll just pretend it's sitting on the left side of the drive. It's going to be channel 0 and 1 on the digital I/O, which is the A and B signals. We're going to create a couple of variables. We want to get the count as an integer. So we'll just declare encoder count. We'll create a double for encoder distance. So we have these two. So now we have our encoder object, we have encoder count variable and encoder distance variable. We should be done with that. We're going to let's do this in autonomous mode. This is where you're most likely to do something like this. In the autonomous init, we have, we're going to set up the encoder and reset it. The reason we want to do that is because an encoder has an counter in it. It counts how many pulses go by, and when we transition to modes, typically you'd want to reset it to 0 so that you know where you are. So we're going to reset that. We can also set another parameter called distance per pulse. Set distance per pulse, and that's going to be some number. It's going to be how far that we've traveled. So let's assume we have 6-inch wheels. So 2 pi r, 2 pi times 3 is the diameter of the wheel. So every pulse will go that far. Or we can just do it another way and just call it 3.14159 times 6-inch wheel times pi. That's also the diameter. But we have to do some division here. We go that distance every 256 pulses. 256 pulses is one trip around the wheel. That sets the distance per pulse. In the autonomous periodic, we're going to periodically, on every click, we're going to read the encoder and see what it's doing. So let's get the count. Get, that's just the simple count. The distance will be from the distance calculation within the class. There's the distance. So it's calculating the distance for us as we go along, but we want to get the count too, just as a sanity check. Remember, we're going to be doing this in the autonomous mode instead of the teleop periodic. We could do it in the teleop periodic if we had a reason to. Last thing to do here, let's just print these numbers out. I'm going to put the number out. I'm just going to shorten this phrase up. Encoder count, and that will be, there's our count. The distance. So we're printing it out to the screen. When we go into the autonomous init mode, we set our distance, we reset the encoders, and on every click we capture the value. Now we really don't need to do this one every time. There's actually a better place to put this, so we'll do that. We're going to go into the robot init. The robot init happens when the program starts up for the first time, and all this code here is done only one time. We only need to do this one time. So I'm going to build the project. Now we deploy it. Code is deployed, the project is started. I'll click this. So we're going to click autonomous here. We're going to do this in autonomous mode. You can see we have the encoder distance, the encoder count here on the shuffleboard. I'm going to hit enable, and I'll pick up the encoder, and you can see some values changing. I'm going to try and figure out where I'm at here, and if I spin it around one time, it should go about 256 clicks, so that's about right. And if you do your math, 2 pi or pi times 6, that's about 18 inches. So that would make some sense here. Let me get to about 256 and see what the number is. And that's about right, 18, 19 inches. So that actually makes intellectual sense. And that's how you implement an encoder and get the count value, and also use the distance function for it to calculate the distance for you.